So the different blue circles in the middle are different pollutants. NH3 is ammonia. Then we have VOCs, means volatile organic compounds, meaning the gas, for example, the gases, pollutants that come out of your tailpipe. We got NOx for nitrogen oxides, SOx for sulfur oxides. And then we have direct PM emissions and indirect PM emissions. What's important here is that direct PM emissions, you see basically coming out of the tailpipe, a lot of them. It's the soot coming out of the tailpipe, plus other direct emissions are also brake wear and tire wear emissions, right? The dust from brake and tire wear, which incidentally we have also for electric vehicles. So electric vehicles are not zero polluting vehicles. We have brake and tire wear emissions at the very least, besides power plant emissions, right? And so they're not pollution free, not even in an urban area. We have brake and tire wear PM emissions from electric vehicles. Besides direct emissions, we also have indirect emissions, right? And those are emissions that are created by other precursors. So for example, in agriculture, we put ammonium fertilizer on fields, which in the atmosphere can convert to ammonium nitrate or ammonium sulfate, and these are particulate matter emissions. And then, you know, if the wind was to blow a lot of this into the urban area, right, it would affect us. VOC emissions, particularly aromatics, are also big, what's called secondary contributors to PM, right? They don't start out being particulate matter particles, but they convert into them. And so aromatics are another big group, as are nitrogen oxide and sulfur oxide emissions. All of those contribute to indirect PM. Next slide, please. And why is that important? For example, what I just mentioned, aromatics emissions in an engine, in a liquid fuel engine, are actually substituted by ethanol. Ethanol provides the same properties, meaning an anti-knock property for your engine, as aromatics provide. So as ethanol gets blended into a fuel, as we can see in this fuel trends report by the US Environmental Protection Agency since 2000, right, we have increased, if I look at the last line, our ethanol from 1% to 9.2%. And with that, we have decreased our aromatics emissions from 28% to 21% in winter gasoline. So as ethanol goes in, harmful aromatics are substituted out, right? And as harmful aromatics are substituted out, we get less PM emissions. Remember, they are precursor. Aromatics are precursor to PM emissions or particulate matter emissions. So that's why this is important to understand as we fuel different levels of ethanol into our vehicles, 10%, 50%, and 30%, we're substituting out aromatics, we're reducing PM emissions.